Okay, the next set of questions, if it looks like this, sine of inverse sine, cosine of inverse cosine, secant of inverse secant, cosecant of inverse cosecant, tangent of inverse tangent, or cotangent of inverse cotangent, those are all really basic. There's one of two possible answers. It's either x or undefined. All right, that's it. So sine of inverse sine of x should equal x unless you can't do inverse sine of x. So that's how inverse functions work. If you square a square root, they disappear, right? They go away, and then what's left is the underneath part. That's all these things are doing. They're inverse functions of each other. They undo each other, leaving you just with x, as long as the domain is not breached. So if it's inverse tangent, inverse cotangent, domain's all real numbers for the argument. So when I talk about the domain, the provided that, we're worried about the domain of the inverse trig function itself. So as long as x does not break the rules, it works. And the first 5 examples from example 2, the first 5 problems, are all that type, where it's a regular trig function of an inverse trig function of x. All right? And they're the same. So sine inverse sine, cosine inverse cosine, tangent inverse tangent, and so on. So these 3 and these 2 are all like that. So basically all you have to do is ask yourself, does this fit into the domain of that? Is that between -1 and 1? Yes or no?
Yes.
Yes, so the answer is 0.357. Okay. This one, is this between -1 and 1?
No.
No, so the answer is undefined. Okay, so that's what you're looking for, is the inverse trig function that's there, does the argument fall into its domain? Next one, it's inverse tangent. Inverse tangent's domain is all real numbers. Is -11.27 a real number? Yes. So the answer is -11.27. So again, that's really easy. If it's trig function of inverse trig function, as long as the inverse trig function can be done, the answer is whatever the x value is. How about the next one?
No.
No. Pi is too big, right? -1 to 1, pi is 3.14 something. So that does not fall into the domain of sine of inverse sine, so it's undefined. And this last one of that type, 0.277, is inside the domain of inverse cosine, so that's going to be 0.277. Everybody comfortable with that? Again, the answer is either x, the number that's there, or you can't do it because the inverse trig function is not possible to be evaluated. The other scenario is this one, inverse trig function of a regular trig function. Okay. If the functions of the form inverse trig of the same trig of x, inverse sine of sine, inverse tangent of tangent, inverse secant of secant. All right, so whatever the trig function is, same trig function. So in other words, it looks like this. If it's inverse sine of cosine, now it's different. They got to be the same. All right. Evaluate the argument of same trig function. So this is going to say sine of something, cosine of something, tangent of something, if it can be done. Sine and cosine, any number can be done. Tangent, cotangent has some undefined. Secant, cosecant has some undefined. They're on your sheet. All right, so it says tangent of pi over 2, that's undefined. It says cotangent of 0, that's undefined. All right, but as long as this has an answer, then evaluate that and then do this the same way you did example 1. Whatever you're going to get inverse trig function of some number, do that the same way you did example 1. So you want to be within the proper range of that function. All right, so let's try it out. This one here, tangent of 4 pi over 3 has an answer. All right, so if you look on our sheet at tangent of 4 pi over 3, it's negative square root of 3, right? I hope my memory serves me right from memorizing that many years ago.
Square root of 3, I got it.
It's positive square root of 3?
Yeah.
Oh, even better. Positive square root of 3. All right. So tangent of 4 pi over 3 just happens to equal that number. That's exactly what it equals. So I evaluate that, just normal trig evaluation. You got a sheet here. You look on the sheet, you find 4 pi over 3, which is right here. You slide over to the tangent column, which is right there. It tells you exactly what it is. All right. Then you have to do inverse tangent of the square root of 3. Now again, inverse tangent lives between negative and positive pi over 2. So even though it equals square root of 3 at 4 pi over 3, we want the answer where it's pi over 3. So once I find the square root of 3, see the square root of 3 here? It's also square root of 3 here, and that lives within our region that we're supposed to be between 0 and pi over 2. So we take the pi over 3 answer, not the 4 pi over 3 answer. Okay. That's as tricky as they get. It's always x, 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 x if it works, and all of a sudden it's not x. But again, tangent of 4 pi over 3 equals something, tangent of pi over 3 equals the same thing. And tangent of pi over 3 lies within our correct range. So that's what we're looking for. Anytime we're evaluating an inverse tangent, we are looking for an answer between negative and positive pi over 2. So that's how you do those, and some of the problems tonight are going to be like that. Trig function of the same trig function, inverse trig function of the same trig function, and then of something. So either undefined, or what x is, or if it's this format, find that and then do that correctly within the proper range.